Today we're going to talk about prisms. Okay, we're going to talk about actually areas and volumes of prisms, and that's what we're going to start with. So before we start, it's kind of interesting. They don't really give us the definition of a prism. They give you a bunch of other definitions about the prism, but they don't really define for us what a prism is. But I think we could actually figure it out. Okay, first of all, what do you think? Well, somebody explain to me what a prism is. Somebody like, if you see a figure, how do you know whether or not you have a prism? Okay, Michelle? It's three-dimensional, good. Okay, it's not two-dimensional thing, is it? Like circles and triangles. It's a three-dimensional figure. What about this? So not every three-dimensional figures are prisms, obviously. How would you know the difference? Like, how would you be able to distinguish? Like if you have three-dimensional figure, right? Not every three-dimensional figure is prism. Yeah. Yes, Grace. What would you like to say? Sure, it has surface area, but no, almost all three-dimensional figures have surface area. What kind of sets it apart? Yes, Hannah?
The bases.
What about the bases?
They're polygons.
They're okay, good. Prisms have bases that are polygons. Not only that, what do you know about these bases? They are one, congruent, and they're also parallel. You're correct. So here's a picture. By the way, okay, so that's actually the definition of prism. But here's a picture of a prism. As you can see, this prism, right? It's a three-dimensional figure. The two bases are parallel. The two bases are congruent. Okay, this prism though, many times we're used to prisms that are like right prism, which means the bases are right on top of each other. This one happens to not be a right prism. Does anybody know what we call this prism? It's called, it starts with O. Oblique is correct. This prism is called, so there are two types of prisms. Listen, guys. There are two types of prisms. One of them is a right prism where the bases are right on top of each other. This one is not. It's an oblique prism. Okay. So let me give you some other now. So now that we know what a prism is, let me give you some definitions. So we have some lateral edges. So let's start with bases. Okay, so the base of prism, like all the polynomial that makes up the prism are called faces. So how many faces are there in this prism, for example? How many faces do you see? No, like I said, every polynomial that makes up the base, that makes up the whole prism, are called faces. How many faces do you see? 8. They are 8 because there are two bases and then all the other faces. So how is the base different than these faces? Well, bases are no, it doesn't have to, because what if you get a cube? Then they're all same shape. So the bases are these are the two parallel congruent polygons, okay, of the prism. So in this case, so that's a good question. Can any side be a base? In this case, with a six-sided figure, can any side be a base?
No.
In this case, no, this would not be. Okay, because the two bases has to be parallel and they have to be congruent. Not only that, these, whatever makes up the lateral face of these bases have to be either a rectangle or, in this case, a parallelogram. Okay, so, oh, can we put this side as a base? Not really, because in this case, the base will be the, because think about, okay, I want you to discuss as a group. Why can the other ones, like these two parallelogram, be a base in this case? Go ahead, everybody think about it. Why not? Why does it have to be this, yes, hexagon. Go ahead, everybody think about it. Why can, so the question comes back to now, why can't, like someone will be asked, why can't one of these sides, the lateral sides, be a base in this case? Does anybody have any answer or idea? Okay, what did we say about lateral faces? They have to be either a rectangle or a parallelogram. If I make one of these sides to be a base, What do you have here? These are hexagon. So one of the size of a prism must be either rectangles or parallelogram. Here we get a hexagon. So that's why I want one. Okay.
Oh.
Was that? But if you have a rectangular prism, how about rectangular prism? Then any size could be basis, but not in this case. So that was a good question. A cube, of course. Cube will also work. Any size could be base. All right, let's move on. So these are bases. Oh, again, altitude of a prism is nothing more than, just like before, what kind of segment do you think? Perpendicular segment that joins the two bases, okay? So it says an altitude of a prism is a segment joining two base planes and the perpendicular to both, okay? So that's obvious. It's kind of similar to what we had. And then of course we use h for height, okay, as usual. All right, we kind of talked about lateral faces already, but lateral faces are, right, faces of, okay, again, faces make up all the faces make up the whole prism, right? But lateral faces are the faces that are not bases. So example, in this case, even though there are 8 faces, how many of these are lateral faces? 6 of those, right? Because 2 of the other ones are bases. Do you see what I'm trying to say? So lateral faces are, right, faces that are not bases. Okay, so basically, kind of. But everything's, yeah, it's the prism is made up of all faces, right? But lateral faces are faces that are not bases. So in this case, how many lateral faces do you have? 6. How many bases do you have? And how many faces do you have? 8. Okay, faces. Okay, it's all of them. All right, and of course, what do you think lateral edges are? Exactly. This is where adjacent lateral faces intersect in a parallel segment called lateral edges. And as you can see, when the two lateral faces meet, you get edges right here. Okay. So pretty straightforward, and then the diagram shows basically what we need. Okay. So go ahead and write it down. I'll wait for you. Okay. So take a look at these 3 prisms. What do you guys notice about all? Well, look at the first 2 versus the last one. Okay, it says lateral edges are the altitude for both of these, right? Look at this one. The lateral edge is not an altitude for the third one. Guess what the first 2 of them are called? What kind of pyramid? Right pyramid. Very good. And we talked about this. Guess what the last one is? Oblique. Okay, so the way we name these, if the lateral edges are the altitude, we include right, and then look at the base. Look at the base of this prism. It's triangle, right? So we call it right triangular prism for the first one. Here it's a right rectangular prism for the second one. And the third one, it's not a right prism, is it? It's an oblique pentagonal prism because the base, right? It's not. Yeah, it has 5 sides. Okay. Oblique pentagonal prism. Are you okay with these? So that's how we define whether or not you have a right prism or oblique prism by looking at the lateral edges. If the lateral edges are the altitude, then you have a right prism. If they're not, then you have an oblique. Okay. So please note that. Okay. So as before, if you're talking about areas, what is going to be the unit for areas, guys? Yeah, unit square. So surface area of a solid is measured in square units. And so let me ask, what do you think then lateral area of a prism is? Anybody have any? Okay, guess. Yes, how about Jocelyn?
The area of the lateral side.
Yeah, exactly. Area of the lateral faces, right? So it's basically, they call it LA, the lateral area. It's sum of the area of the lateral faces is the lateral area. Pretty straightforward, right? Okay, so that's what we mean. So on your homework tonight, they're gonna ask you to find LA, and it stands for lateral area. And so these are basically sum of the areas of the lateral faces. Okay. Yeah, well, when I give you homework in this section. Okay. All right. So then, Katie, what do you think we mean by total area of a prism? Any guess?
The lateral area plus the area of each of the bases.
Exactly right. So total area is same thing as lateral area, but you add the faces. So here's a simple formula. Because we, remember, what do we know about the 2 bases of the prism? They are congruent, right? So therefore, you just multiply 2 by that area of that base. So the formula for the total area, simple, is lateral area plus the two of the bases. Okay. Okay, so let's move on. That's pretty straightforward. I'll give you time to write. Go ahead. So it turns out, actually, to find the lateral area of a right prism, so when the prism is right prism, it's really easy to find the lateral area. If it's not right prism, you might have to do some work. But if it's a right prism, okay, to find the lateral area is really straightforward. Anybody know? What would you do if I gave you a prism and it's a right prism? How would you find the lateral area for this? One person? Go ahead, discuss with your group. What do you guys think? What would you do to find the lateral area? So here we go. How would you find the lateral area of a right prism? How about, let's see. Let me see, somebody random. How about Jack? What do you think?
I think it is the altitude times the base times the amount of sides.
Yeah, depending on how many sides you have, right? You basically, right? You add up all the lateral faces, right? You add up all the areas of lateral faces, right? That's easy. That's pretty easy. But it turns out there's an easier way. It turns out you could do this. You could actually do that, which will give you the same result if you do this. The perimeter of the base times the height of this pyramid. So what Jack said is correct. I mean, you could, of course, add up all the lateral area, right? That's how you get the lateral area, right? I mean, you add up all the lateral faces, you get lateral area. But where are they getting this perimeter of the base and so forth from? So I want you to write this down, and I'm going to show you something. Yeah, I'm going to show you something that would help you to understand why this is true, okay? Here we go. So let's take a look at this. What do you see here, guys? You see, I think, okay, it's kind of open. So if I do this, what do you see now? It's a rectangular rectangular prism. Okay, actually it's a square prism, right? Okay, now what happens if I were to open this up? Well, you get a bunch of rectangles and squares. So what are these two? These are the two squares. Yeah, these are the two bases. Now look at this. One of you said, you know, to get the lateral area, why not add up all the lateral faces? You see 4 of them here, right? Yeah, you could do that, but yeah, it'll take longer to do that because what's this whole thing? This is basically a big rectangle, isn't that right? Well, do you know how to find the area of a rectangle? Well, what was this? This side was the height, and what is this one plus this one plus this one plus this? Yeah, it's the perimeter of this base because doesn't it wrap around the whole base? Right here. You see? You see how it wraps it around? So if you open it up, right, the whole thing, this is a perimeter, right? Let's look at a different one. I have another one here. Take a look at a right triangle prism. It looks like a triangle, but if I do this, you can see it's a prism, right? Okay, so let's look up here. Now, let's open it up. What do you get? Again, you get 2 bases, and then if I'm looking at the lateral area, it's basically a big rectangle, isn't that right? Well, what is the dimension of this big rectangle? It's the height of that prism times what's this plus this plus this? The perimeter. Does that make sense? All right, let's look at. I have another one. Okay, so what do you see here, guys? Pentagon. But if you do this, you can see that it's a right pentagonal prism. What happens if I open this up? You get a bunch of, yeah, exactly. You get, so look at the lateral area. It's nothing more than a big rectangle, and it's the height of this prism, right? What's this plus this plus this plus this plus this? Perimeter of the base. Does that make sense? Because again, it wraps around. Doesn't this whole side get wrapped around on this, right? Base? Does that make sense? So you see where we got that formula, which says what? Which says the lateral area of a right prism equals to what? Perimeter of the base times the height of the prism. Yeah, you could of course add up all the lateral faces, but isn't this a lot easier? Okay, especially for a prism, right? Okay, so does this make sense? Yes. All right, so here we go then. Let's move on to the other part. Okay, good. All right, take a look at this. Somebody read this for us. How about Leah? Can you read this for us? Prisms have?
Prisms have volume as well as area. A
Mhm.
rectangular solid with square faces is a cube. Since each edge of the blue cube shown is 1 unit long, the cube is said to have a volume of 1 cubic meter.
Good. So just take a look at this blue cube, right? This cube is made up of base and height and the length, right? It's all one by one by one. So therefore, we call this volume 1 cubic unit, right? So if this was 1 meter by 1 meter by 1 meter, it'd be 1 meter cubed, right, guys? So imagine then, what if I have not just this one of them, but what if I have this whole rectangular prism? What will be then the volume of this whole thing? Well, how many of these little cubes, right, will fill up this whole volume, or is it made up of this, right, small cube? How many of these do we have? Well, look at the bottom. I got 4 and then plus 2. So how many do I have on the bottom shell? That's 8. Well, I have how many layers of that? 3. So what's 8 times 3? Isn't that how you figure out how many of these square, right? How many cubes I have? So therefore, the volume of this whole thing is what? 24, not 12. There are 24 of these, right, cubes, don't we? So it'll be 24 cubic units. Is that right? And does anybody see the formula to figure out the volume of this whole thing? Yes, David. Yes, it's basically base times width times height. In other words, well, this base times width is not just the area of the base. So for a simpler way, we just say the volume, write this down, the volume of a right prism equals to the area of the base times the height of the prism. So it's V, capital V equals to, do you see how it's capital B? Capital B represents what? Area of the base. If I just say little b, that's just the base of maybe a triangle or right? Something. But notice it's a capital B. Please note the difference. Capital B means the area of the base, as it says up here. Okay, area of the base times h. Okay, the h is not capitalized, right? H is just the height. Does that make sense? So write that down. So whenever you see in these formulas, if you see a capital word like B, that means it's the area of the base. Okay. So write that down. I'll wait. Okay. Okay, let's look at some example. Sorry, got caught off a little bit, but it says you have a right trapezoidal prism, and it says find the lateral area, total area, and the volume. So knowing all those, okay, let's review a little bit. How do we find the lateral area? Perimeter times the height. Very good. How do we find the total area? Well, you add the area of the two bases to the lateral area. And how do we find the volume? No, it's not base. It's the area of the base, not base times height. Because base times height, you get a rectangle, you know. It's area of the base times height. Does that make sense? Go ahead, everybody go ahead and do this. Okay, you can work as a group. Go ahead, I'll wait for you. So, let's look at the first lateral area. Now, to find the lateral area, what is the thing that you have to find first to find the lateral area? Using the formula, it is the, very good, perimeter. So, you just add 5, 6 plus 5, 12. What do you get, guys? Okay, 28. So of course, if the perimeter is 28, and if the height of this prism is 10, of course, everyone should know then the lateral area is nothing more than 280. Okay, and of course, centimeter squared is. Any question? Easy enough. All right, let's look at then the total area. All you have to do is find the two bases now added together, right? Who remembers how to find the area of the trapezoid? How about, let me ask David. That's right. So you add the bases together, multiply that by height, and divide it by 2. Okay, good. So when you do, you should have gotten 36. Okay. So of course, do I add 36 to 280? That's how you get it wrong. How many of these bases do we have? 2. So it's 280 plus twice of 36 comes out to 352. And of course, to find the volume, because we just found the area of the base, it's easy to find the volume. Isn't that right? So to find the volume, what do we do? How about Joshua Park?
Over there.
Oh, Joshua Park? Yeah, right here. Joshua Park? How do you find the volume? Area of the? Good, area of the base times height. So we just found that the area of base is 36, right, Josh? So then, what's the volume? 360. What should your unit be? Centimeter Centimeter cube is correct. Very good. Okay, did you all get that? All right, so, and quickly, let me show you the last one here. It says find the height. Well, it says a right triangular prism is right there. The volume is 315. Now, this time they give you the volume. They ask you to find the total area. Well, to find the total area, what do you have to find? Height, correct? Okay, so this one, people mess up on the most because here's the place. When you find the area with base, what do you have to do? Base times height over 2. That's where people mess up. They forget to divide by 2. So what is your formula going to be? 315 is equal to what? Area of the base times height. So please don't forget to put half times 10.5 times 4 times h. Right? Does that make sense? Because people see that it's a triangle, but they forget to divide it by 2. When you do, you should get 15 as the height, and of course, to find the total area, you find the lateral area and add the 2 bases. Okay, again, 2 bases. These are triangles. Don't forget to divide by 2. Any question? This is pretty straightforward. So this one, they give you the volume. You have to find one of the unknown and then find what they're asking. Easy enough? Okay, good. Can you do something like this for your homework tonight? Okay, guys, have a good day.